Welcome to your Intro to Stat, Lesson 1.2. Today we're going to talk about various types of random sampling and also some types of sampling that don't involve randomness, which aren't so good. Alright, but let's start off by talking about what a random sample is. It's a sample of some fixed size, say n, that uses chance to pick its members and gives every member of a population an equal opportunity or chance to be selected. The benefit of this is that you get a representative sample and you can generalize your results to the entire population. Now, a very special kind of random sample is a simple random sample, and it's the only kind that is represented by SRS. If you write SRS, that means simple random sample. A simple random sample of n measurements from a population is one selected in such a way that every sample of size n from the population has equal probability of chance of being selected. This means that every individual also has an equal probability of being selected because that is the case in which n equals 1. But it also has to be, if you're doing a simple random sample of size 100, every sample of size 100 has to have an equal opportunity of being selected as well as each individual. One way to get a simple random sample is to write the name of every member of the population on a different slip of paper, put the papers in a hat, mix well, and draw the papers without looking, and you will have a simple random sample. There's other methods, but that is one. Alright, so back to our woodchucks. Woodchucks and groundhogs are the same animals. Who knew? Suppose I wanted to estimate the proportion of Houston Christian students who know this fact. How could I select a simple random sample of 60 students to ask? I could get a list of all students and write the name of each student on a separate slip of paper. I would put the slips of paper in a big hat. Then I could mix up the slips of paper and select 60 without looking. The students with those names would comprise my sample. Another thing you can do is use the random digit table or random number table. If you label people or other items to be selected for samples with numbers, you can use a random number table to help you select the members of your sample. All the labels you use have to be comprised of the same number of digits. In other words, if there are 80 people in your population, then you would need to use labels 0, 1, 0, 2, 0, 3, 0, 4 on up to 78, 79, 80. So that everybody would have 2 digits. Suppose I have 50 woodchucks in my laboratory and I want to sample the weight of 5 of them. Starting with line 6, use the random number table in your book to help me select my 5 woodchucks. So if you don't have your book right there with you, stop and go get it. Okay. First, you would label your woodchucks 0, 1, 0, 2, 0, 3, all the way up to 47, 48, 49, 50. So we're going to start with line 6 because that's the line we were told to start with, and we're going to take the digits 2 at a time, and the first pair that are between 0, 1, and 50 represent the first chosen woodchuck. Okay, so the first pair of numbers is 28, so we're going to choose that woodchuck. And then we get 70. That's not in the range, so we skip it and go to the next 2-digit pair. So 35, we're going to choose it. 17, we choose it. 09, we're going to choose it. 94 is not in the range, so we skip and we go to 45. And that is in our range, so we're going to choose woodchuck number 45. So my 5 woodchucks sampled would be 28, 35, 17, 9, and 45. But let's say before we got to 45, one of these other pairs of numbers that represent a woodchuck showed up again. Let's say 17 showed up again. We would ignore 17 just like we do 94 and 70 because one woodchuck can't be selected twice. In other words, you wouldn't ever have 28, 35, 17, 09, and 17. You have to choose a different one because remember, each of those numbers represents an actual little critter. Okay. What if I get to the end of the line? Keep on going to the next line. What if I'm not told a starting line? Well, then pick one and report it. What if there were 100 members of the population? Then use 3 digits, 001, 002, 003, and so on. Okay, there are other sampling techniques, and as long as they use randomness, they are considered good techniques. One is stratified sampling. The population is first divided into groups called strata that share a common characteristic. Then an SRS of a certain size is drawn from each strata. The little SRSs are combined to make the stratified sample. Another method is systematic sampling. A random starting point is selected, and every kth person is selected as a member of the sample. So you pick a place to start, and maybe it's every 10th person or every 8th person. That's what kth means. When this method is used, it is assumed that the members of the population are arranged in some natural sequential order. Be careful if you're sampling from a population that is cyclical in nature. If you want to know the average time a student wakes up, then you would not want to start on a Saturday and take measurements every 7 days, because all you're going to get are Saturday wake up times, which might be maybe systematically different than, say, the wake up times Monday through Friday. Cluster sampling. A population is divided into several heterogeneous clusters. A simple random sample of a certain number of clusters is chosen, and every member of the cluster is included in the sample. And this is used extensively by government agencies and certain private research organizations. A convenience sample, this is not necessarily a good sample because it doesn't really use randomness at all. The problem is that there's not really a larger population to generalize to. And this is using results or data that are readily available, that are just convenient for you. And they're usually severely biased, and you can't generalize to a larger population. Okay, so back to our woodchucks. Remember, I want to know the proportion of HCHS students who know that the groundhogs and woodchucks are the same animal. I want a sample of 60 students. Here are examples of the various kinds of sampling. So for stratified sampling, that would be I get a simple random sample of 15 freshmen, 15 sophomores, 15 juniors, and 15 seniors. The thing is that I divide them into their groups by classification before I do my simple random sampling. If I was going to use the hat method, I'd have 4 different hats. I'd have a freshman hat, a sophomore hat, a junior hat, and a senior hat. And I would draw 15 people out of each hat. Systematic sampling, I line up all the students according to birth date. I roll a die for my starting point. So if it lands on with 4 dots up, if it lands on a 4, then I will start with the 4th student and then include every 8th student in my sample. Cluster sampling, the school decides to divide up the students into 6 heterogeneous groups for a field day competition. In other words, each group is like a simple random sample from the whole school. Each little group should be representative of the school population at large. I decided to roll a die to randomly select one of these groups, then I include every member of that group in my sample. Convenient sampling, that would be just like if I stand in the hallway and ask the first 60 students I see, or I just ask 60 of my students. That's not going to necessarily be representative of a larger group. Okay, be careful with voluntary response samples. They overrepresent people with strong opinions. All right, now with a convenient sample, I still select people to be part of my survey. I go out and ask them to be part of my survey. I just do it in a way that's convenient for me. Voluntary response would be like if I got up during family time or chapel and said, "Hey, I want to know about your opinion about late start days or some other issue." And I just take the first 60 people who come up to me, but I make it just like an open call to everybody, and individuals select whether or not they want to be part of my sample. That's a voluntary response sample. For a convenience sample, that's when I go up to people and ask them questions. Okay, I still select who's in my sample for a convenience sample. For voluntary response, I just kind of put a big open call out, and the subjects select to be in my sample. Hidden bias occurs when something in your methodology causes you to accidentally measure something other than what you intended. Okay, you just, the way you ask the question, you're going to get a different answer, or in the way that you select the people, that's called hidden bias. Lurking variables can actually be the cause of apparent relationships. You think that the data you're looking at are telling you that one variable causes the other, but there could be another variable in the background that make it seem like there's a relationship. Another big problem is generalizing results when your sample is not representative of your population, and that's going to create an incorrect picture. You're going to think something is true about the population that just isn't true. Okay, that's it for lesson 1.2. Do the problems to try on your own. Come to class ready to work. I will see you in class. I hope you have a great day.